Well, hello there. I've been asked to solve some more questions. So here we go. So this one is from Student Assessment 3, and this is question 7. All right, so this is about light years as well. So distances and space. This is one of the practical applications we were talking about. So let's have a look at the information given to us. So we're told the speed of light is 3 times 10 to the 8 meters per second. And we're told that the place we want to go to is 108 million kilometers away. So the first thing I'm going to notice is that this is in kilometers and this is in meters. So what I'm going to have to do is turn this into kilometers per second instead of meters per second. So what I'm going to do is think about, well, there are 1,000 meters. Whoops, 1,000 meters is 1 kilometer. So I really need to divide this by 1,000. Which means that I just need to take off 3 zeros from this, right? So 3 of these, take away 3 of them. Well, now I've converted it into kilometers per second. All right, so if we think about our triangle, our distance, speed, time triangle, so distance, speed, and time. Well, we are interested in finding distance, right? So no, we're interested in finding time. We want to know how long it's going to take. So we want the time is going to equal distance over speed, right? That's what our triangle tells us to do. So the time is going to be the distance. Now I'm going to put this into standard notation. All right, so then how many places did I move the point? 1, 2, 3, 4, 5, 6, 7, 8. I moved it 8 places. So times 10 to the 8 divided by the speed, which we have is 3 times 10 to the 5. So what I'm going to do is divide the numbers and divide the powers. So 1.08 divided by 3 is 0.36. And remember, when we're dividing, we subtract the powers. So this should be 10 to the 3. So what I'm going to do is just make this a number, right? So 3 means I have to move it 3 places across, which gives me 360. Now, what unit of time are we talking about? Well, if you have a look at what we were measuring in the first place, this is seconds. Now, the question asked for minutes. So if I've got 360 seconds and there are 60 seconds in a minute, it's going to take me 6 minutes. Well, not me, it's going to take a light 6 minutes to travel that distance. Okay, let's look at the next one. What I'd actually like you to do is pause this video. I'd like you to try and do, if you have not done the rest of the questions with space distances, please pause this video and try and do it yourself now that you've seen me do this, because I'm about to do Student Assessment 4, question 7, which is identical to that. So pause this, have a go at Student Assessment 4, question 7, and then you can check it with my answers. So here we go, Student Assessment 4, question 7. All right, so this one, again, we've got the speed given to us, 3 times 10 to the 8 meters per second. And we are given the distance, which is 778 million kilometers. Again, I'm going to notice that this is in kilometers and this is in meters. So the first thing I'm going to do is turn this into kilometers in the exact same way I did before. I'm just dividing it by 1,000, which is 3 zeros taken off. All right, let's again look at our triangle. Again, this is exactly the same as last time. Distance, speed, and time. And we are still trying to work out this time we're trying to work out speed. Okay, before we were working out time, speed, but it's exactly the same thing, right? We're still dividing distance over time. So the speed is going to be, did I write this down incorrectly? Let me just quickly check the thing. The speed of light, no, I've written this bit down correctly. We're not being asked to find speed, we're asked to find time again. Let me just double check the question. Calculate the number of minutes. Yep. All right. Time equals distance over speed. I've written it down wrong. Okay. So time is going to be the distance. Again, I'm going to turn this into scientific notation or standard form. times 10 to the power of, well, 1, 2, 3, 4, 5, 6, 7, 8. All right, 10 to the 8. And my speed in kilometers is 3 times 10 to the 5. All right, same thing. I'm going to divide 7.78 by 3, which gives me 2.593 times 10 to the power of 8 minus 5 is 3. But this is, well, let's move it 3 places. So 1, 2, 3. So 2,593. But again, we're still in seconds. So I need to divide by 60. So 2,593 divides 60. So I can get to minutes is 43.2 repeating. And that is minutes. Now, this question does ask for 3 significant figures, so you don't need to write this repeating because 3 significant figures just means 3 numbers where the first one is not 0. So that would be fine, 43.2. All right, let's do question 8. Again, feel free to pause this and have a go at it yourself. So student assessment for question 8. So it's still space distances, but we're being asked to find something else this time. This time we need to find the distance. So we know that it's 300 light years away. Wait, we're not trying to find distance. Let me read the question. We are trying to find, oh no, we are asked to find the distance, sorry. Okay, so a star is 300 light years away. And obviously light years, yeah, we don't really know what that means. Okay, so the speed is the same, 3 times 10 to the power of 5 kilometers a second. This time it gave it to us in kilometers already. Fantastic. That makes life a little bit easier. We don't need to do anything in the first place. So my distance, well, actually, let's make our triangle again. Distance, speed, and time. So this time we are trying to work out the distance, which is speed times time. Now, the first thing I need to do is have a think about turning 300 light years into seconds, right? This is years versus seconds. So I'm going to have to do some work here. So I've got 300. I'm going to have to times that by 365 days in a year, by 24 hours in a day, by 60 minutes in an hour, by 60 seconds in a minute. And that is going to give me 9.4608 times 10 to the power of 9. So either you could have written it out, 9, 4, whoa, I'm getting a phone call. That's not great. I'm going to hang it up. Sorry about that. 94608. My computer rings if I don't pick up my phone. That's annoying. And I need to move this 9 places, right? So 1, 2, 3, 4, and I've still got 5 left. So 1, 2, 3, 4, 5. Okay, so either way, I've just written it straight in standard notation because I need it like this, but that is obviously the same number. Okay, so if distance equals speed times time, the speed is 3 times 10 to the power of 5, right? That's this up here, times this, our time is 9.4608 times 10 to the 9. Now, remember the commutative law, these brackets don't mean anything. I can rearrange this however I like. 3 times 9 times 10 to the 6 times 10 to the 9. I'm allowed to rearrange it. This makes life a lot easier. So 3 times 9, obviously pretty, oh, sorry. Why did I write 9? It's not 9. It's a big giant number. Times 9.4608. There we go. That makes more sense, doesn't it? Times 10 to the 6. Nope, that's a 5. I can't read my own writing. Times 10 to the 9. All right. So then this number here, 3 times 9 point whatever or other, is going to give us 28.3824. Times 10, and remember when I'm multiplying, I just add these numbers, so this is 14. So this is my answer, but it is not in scientific notation yet because I have more than one number in front of the decimal place. So I'm going to write it like this. and I moved it one place. So I have to add another number to the power because I've moved it one place across. Now, the question actually asks you to give the answer in 3 significant figures. So again, you only need to write 3 numbers after anything that's 0 times 10 to the 15. So this is the final answer they're looking for. All right, if you didn't understand what I was talking about and you'd like to go through some more, please let me know. Otherwise, we're done.